Mount Everest contains roughly 160 trillion pounds of rock and ice, a mass so vast it exerts its own measurable gravitational pull on the surrounding crust. Now, imagine taking every gram of that mountain and crushing it until the entire mass fits inside a standard coffee cup. At this density, the gravitational field becomes so concentrated that the internal structure of atoms can no longer support the weight. The entire mountain would violently collapse into a single, infinitely dense point in space, leaving behind only a sphere of absolute darkness. Even at the size of a coffee cup, this object now functions with the same physics as the most destructive anomalies in the known universe. The physical size of a black hole is merely a byproduct. The true power comes from gravity winning the ultimate battle against the structure of matter. This process happens naturally when the most massive stars in the universe run out of fuel and collapse under their own weight. The resulting stellar mass black hole contains the equivalent of 3 to 10 of our suns. All of that solar mass is compressed into a sphere approximately 10 to 15 miles across. On this map of a metropolitan city, the black circle covering the downtown district represents the total physical footprint of that multi-sun mass. This boundary is the event horizon, the point where the escape velocity required to leave exceeds the speed of light. An object that could fit within your morning commute possesses enough gravity to ensure that nothing, not even light, can ever exit. To see how these scales evolve, we have to look toward the center of the Milky Way. This is the home of Sagittarius A star, the gravitational anchor for our entire galaxy. It contains the mass of 4 million suns, all packed into a single region of space. At this scale, city maps are no longer useful. We have to use the distance between planets as our ruler. Place the Sun at one end of this ruler and Earth at the other, and Sagittarius A star's event horizon fills the entire 93 million mile gap. This void is wide enough to swallow the orbital paths of Mercury and Venus, along with the Sun. At this magnitude, the black hole functions as a permanent puncture in the fabric of the galaxy. But even Sagittarius A star is small compared to the giants found in the deep cosmos. Astronomers have identified a class of ultramassive black holes that represent the absolute limit of what the universe can produce. These anomalies carry the weight of 60 billion suns. On this scale, the event horizon expands until it swallows our entire solar system, reaching past every planet we know. Here, our entire solar system, from the Sun to the Kuiper Belt, is reduced to a single dot against the curve of the horizon. These structures represent the maximum amount of matter the universe can concentrate in one place before our current understanding of physics breaks down. From a simple coffee cup to a sprawling city, across the Earth-Sun gap to the solar system's edge. Despite those differences in size, the physics remain identical. The darkness inside the smallest stellar black hole is no different than the darkness within an ultramassive giant. The universe applies the same rules of gravity, regardless of the scale. Gravity simply finds larger and larger stages to occupy. Follow as we continue to map the true scale of the cosmos.